Hello guys, in this video we will build a simple XOR encryption in Python. Now traffic encryption is one of the most powerful techniques to evade network analyzer or IPS sensors. But first, and before jumping into the coding part, let's have a quick overview on how these devices work in the first place. Generally speaking, these devices can operate in two modes. The first mode, which is the signature-based mode, where it inspects the packet parameters and data payload which are passing through the sensor. Then, similar to an antivirus, it checks if there is any match against its signature database. And based on the action specified for the matched rule, it may drop or lock the traffic. The second mode is behavior-based or anomaly-based, where you install the IPS in the network and the IPS will learn the types of the protocol as well as the packet rate passing through the sensor. Then it's gonna build its database or its baseline database based on the current network traffic. For instance, in this network, let's say that we have 50 PCs are usually use SSH to access a remote servers. Now, if the IPS is working on behavior based, it will learn that on average we have 50 SSH sessions and it will create a baseline for this. Now later on, for some reason, if any PC has used Telnet, then the IPS will consider this protocol as a suspicious activity and may drop the packet. Keep in mind that the Telnet session is a legitimate session, but since the IPS during the learning phase did not notice any Telnet session, it won't be included in the IPS baseline, and this wrong behavior called false positive. This is why behavior-based IPS are not frequently used due to these false positive. Now we will code a very simple XOR encryption to mask our data payload. Now you're probably saying, why an XOR encryption? Why not creating an SSH or HTTPS shell, since this protocol provides encryption by design? Well, I do not recommend this because in many enterprise network you may find your target has installed a decryption device where it can terminate the SSL and SSH. So let me just draw that for you really quick. So this is the device which can terminate the SSL or SSH and convert it into clear text. So basically, once the traffic comes into this device, it will convert or remove the encryption from this protocol and convert it into clear text before passing it to the IPS sensor for inspection. So technically, you won't have an end-to-end encryption shell, and if your shell faces this decryptor device, you won't have any added value. And one more note here, by the way, many modern firewall or next generation firewall can terminate the SSL and SSH encryption for inspection purposes. Alright, let's jump to the coding part. And let me just minimize this PDF file and open our script here. Okay, let's move to the first section. And first of all, we will generate a random key which will be used for the XOR encryption. Now our key should be complex enough and match the following criteria. It should contain lowercase, uppercase, digits, and special characters here. Now, the for loop at the end defines the key size. The key size is 1 kilobyte, which is, if you remember, in our TCP shell, it matches the TCP socket size. The empty string .join will put the result for the random strings into a sequence, and finally we will store it in a key variable. So all in all, the for loop will generate a 1024 random string which are matching our criteria, and the .join is used to gather these strings into a sequence. Now let's run the code and have a look on the output. Okay, and this is our generated key that we will use for encryption. And at the end, we print out the key length here. As you know, the key length is 1024 bytes. Now, if we run the script one more time, we should see a totally different key with the same size. In the second part here, let me just uncomment these lines here. In XOR encryption, keep in mind that the key size should be equal or greater of the clear text message. So this is the message which we will encrypt, and then we will print it out in a clear text. Moving on, here I have defined a dedicated function called XOR. So we will pass two values to this function. The first value is the message that we want to encrypt or decrypt, and the second parameter is the XOR key. Notice that the same key is used for both encryption and decryption process. Also, the message could be the encrypted message that we want to decrypt, or the clear text message that we want to encrypt. So once again, the XOR operation is exactly the same when we encrypt or decrypt. The only difference is that when we encrypt, we pass the message in a clear text, and when we want to decrypt, we pass the encrypted message. This line does both the XOR encryption and decryption for us. So first, we split the message and the XOR key to a list of character pair in tuples format. Next, we will go through each tuple and convert them into integer using the OR function. Now once they converted into integer, we can now perform an exclusive XOR on them. Then the last part, we will convert the result back to ASCII using the character or the CHR function. At the end, we will merge the resulting array of characters as a sequence using the .join function here. Alright, so in summary, we will print the clear text message, then the encrypted version, and finally the decrypted one. So for now, let me fire up the script here. And as we can see, this is our XOR key here, and this is the message. and this is the message after encryption, which the IPS and the word will see, and the last one is the decrypted one. Now notice, each time we run the script, a new key will be generated, and hence a new encrypted message will show up. So this is the old encrypted message, and this is the new one, after generating a new key for sure. Last note, once you generate your XOR key, make sure that the same key is hard-coded into your Kali server script and the Windows backdoor. Otherwise, you won't be able to decrypt your messages. That's it for this video. Thank you for watching.